Hello there, my fellow AP gurus out there. I'm hoping that you can help clarify things for me. I think I know what I'm doing here, but I just want to make sure that I am and see what your thoughts are. So, I'm dealing with electroplating from Big Idea 3, and I guess what I'm looking for is if I were plating zinc onto a copper electrode, so going through an electrolytic cell type of situation here. I guess my question is there a minimum voltage needed to have that happen? And in the past, what I've generally told my students is no, there's not. And my reasoning behind it, and I'm going to be using, I don't know how well this will translate and you'll be able to see, but my first thoughts are if you set this up with a zinc solution.
Tyson Monahan, please come to the main office.
Sorry about that. If I have a zinc solution and I have a copper electrode over here and a zinc electrode over here, and then I set it up with my battery and I turn my battery on and I run the voltage, I send the electrons over to the cathode over on this side. My thinking is that the zinc solution is going to be reduced there and it's going to form zinc metal, and over on the other electrode, the zinc electrode there is going to be oxidized and go and form more zinc solution. And then when you look at those two half reactions, you have the oxidation, which would have a cell potential of 0.76, a reduction of negative 0.76, and when you add them together, you get the E cell equal to 0. But of course, this won't happen unless you actually do connect it to a battery or a power source. So you do need to have a little bit of current going through there, little bit of potential going through there, but the potential itself is negligible. You don't need a whole heck of a lot. You just need to have more than not having it hooked up in the first place. So that's my first thought. That's what I've generally taught my students over the years. I have heard, though, some other people talking and seen some videos where they've mentioned that this reaction would be kind of the reverse reaction of zinc with copper solution. And so if you do that all backwards, just the normal galvanic spontaneous reaction or thermodynamically favored reaction, that one gives you a voltage of 1.1 volts. So if you reverse it, I've heard some people talking about how you would need a minimum voltage of 1.1 volt to make this reverse. I don't like that explanation because in this particular case, I don't see copper that's being oxidized in this solution because we don't have copper going to form the copper plus 2 at the anode, and I wouldn't think that you would because you've got zinc at that anode. So I don't like that explanation that I have up there. And then the other possibility is that your zinc solution, whatever the anion was that normally would be a spectator ion, that maybe that's being oxidized at the anode, and you would have to take that into account to calculate a minimum voltage. Again, I'm not comfortable with that. So I usually tell my students that while the E cell is going to be 0 because you have zinc being oxidized and zinc being reduced in the same zinc solution, you do have to have it hooked up to a battery. You do have to have some current, and then you can do all those current calculations for how much would plate in a given amount of time. But you ultimately, there is not a minimum voltage. So please let me know if my thinking is correct on that, or if you have other thoughts. I value any kind of input you could give me, and I really thank you for your time on this.